Hello and welcome back to Deep Linux. Um, I'm creating this video on the very first day of 2026. First of all, Merry Christmas, Happy New Year to all you audience. And I'm going to talk about something that has always been interesting for me since I was a junior computer engineering student. It was always interesting for me to know how the operating system, in this case being Linux, handles keyboard input or mouse input and things like that, right? So when you type something, how is that handled? Or when you move the mouse, how Linux takes care of the mouse pointer and everything? How is actually input given to your computer? And I'm talking about this from the OS perspective, not really about the hardware here. So today, on the very first day of 2026, I've decided to quench my thirst and yours, for those who are also curious just like me, and show you how Linux would handle input from mouse and keyboard. Okay. The first place I would start is because these are devices, right? So this is kind of like an I/O. Okay. I would start with interrupts. I would try to understand what interrupt takes care of mouse and keyboard movement. So to give you a little bit of context, I have here a laptop which has USB-C ports, so Type-C USB ports, and I have a wireless mouse that is connected to one of these USB-C ports through a wireless dongle, and then through an adapter. I guess you guys know what I'm talking about, right? So there's a USB-C to USB adapter, right, that plugs into my laptop. Then there's a wireless mouse dongle, and then there's my wireless mouse moving around. I also have a touchpad. I'm guessing that most likely the source of interrupts would be different from for the touchpad and the wireless mouse. And then I have my keyboard. Okay, so the keyboard is just like a normal keyboard installed, like the built-in keyboard of the laptop. Okay, so to check on the interrupts, we should look at the file cat proc interrupts. These are all the interrupts that we have. And I'm just gonna make this a little bit bigger. And as you can see here, we have all the interrupt numbers, IRQ numbers here, and then the core, the CPU core that serves that interrupt, basically how many times this interrupt 9 has been served by CPU 1 and so on and so forth. So sometimes some interrupts are only served by one core, sometimes they're served by multiple cores, and this is called interrupt affinity, meaning that what set of CPUs each interrupt is tied to. Okay. So what I'm going to do is I'm going to, and then here at the end, you have some description of the interrupt, and here at the end, there's the device. There's the device, most likely this is the driver name as well, that issues these interrupts, okay? And here you will see if the interrupt is edge triggered and whatnot, right? So I'm not going to go into that for now. Okay, so let me set a watch on this. Just going to say watch with interval of 1 second and highlight the differences for this proc interrupt. Okay, and I guess this much is fine for me. So you can see that as the interrupts come, these counters are bumped up, and then any changes would be highlighted like that. Okay, let me just blow this up a little bit. Should be enough, I believe. Yeah, okay. Now, okay, so first off, I'm going to check the keyboard, okay? So I'm just going to press my cursor buttons because I don't want to mess up the display here anyways. Let's pay attention to what interrupt count goes up. Did you spot anything? Okay, I'm just going to let go. Okay. Pay attention to CPU 7. Pay attention to this guy. Pay attention to this. Okay. Again, pressing the button. So you see it's interrupt number 1, which is triggered on CPU 7. This one. Interrupt number 1. I8042. This is the legacy interrupt controller that, there used to be like an interrupt controller. So this is it. So I-8042, right? That's where the keyboard interrupt comes from. This is the real-time clock, for instance, but this is it. This is it. So it comes from one of these legacy interrupt controllers, and it's interrupt number 1. But let's just double check again. Okay, make sure no other interrupt pops up. See, these guys, for instance, they're always there, right? So I wouldn't really care about these. But let's pay attention. Okay, pressing. Releasing. There you go. So that's interrupt number 1, okay, with this name. So we're going to pay attention to that. Now, let me play with the with the touchpad. Pay attention what interrupt pops up. Did you spot it? Yeah? Which one? Releasing now. Okay, one more time. Now pay attention to this one. Interrupt number 40 here. And this one, interrupt number 96. So 40, 96, which is IDMA 64 dot whatever, and then the DLL 0945. Okay, pay attention to these two. Playing with the touchpad, you see the counts are going up and then releasing. See? Okay. So I also know what interrupts correspond to my touchpad. But let's play with the mouse. So I'm now playing with my wireless mouse. See, these two interrupts aren't really bumping up. Nothing. Actually, I don't see anything here. Nothing shows up. Right? Nothing changes. Well, there's a reason, because my microphone happens to also be connected through the USB-C set of ports. So maybe its interrupt is overlapping with the mouse, because there's a mouse and a microphone connected to the same PC, to the same USB device, right? Maybe different USB devices, but to the same USB hardware, right? And maybe they're sharing interrupts. So that could be something. And if I wanted, let's just verify that. So I'm just going to disconnect my microphone, and if I mute it, it's not going to happen, because mute is something at the software level. I have to disable it at the hardware level. So I'm just going to unplug my USB microphone and pay attention to any of these changing. I hope that doesn't messes with my audio here. So unplugging now. Okay, did you detect anything? Pay attention to this one. Pay attention to this. Interrupt 166 named XHCI-HCD. Pay attention. So now I'm speaking, right? That there are interrupts there, but okay, it's a little bit, changing a little bit. Now I'm going to plug in my microphone, USB. So it is plugged in. Now you see that as I speak, the counters are going up in the 4 digits, right? Before that, it was only 2 digits. So you're getting a load of interrupts there, right? It's going up. So you can see right here, see? These are really going up. So 9, 7, 12, it's like by thousands. It's going up by 1,000 every second, okay? And if it's packetizing voice with 20 millisecond intervals, let's say, then I would expect like 50 interrupts at least, but maybe it's going to be even more than that. Who knows, right? So I'm just going to unplug it again and watch for that drop in that count. That is unplugged. And even though I'm speaking, you see that it's going 70, 74, it's not that much, okay? Now, what I'm going to do is I'm going to move my wireless mouse pointer. It's going into, the changes are going into the 3 digits, okay? Now, releasing my mouse, not moving it. Okay. Back down again. Moving the mouse. Changing by the hundreds, right? By the hundreds. Releasing the mouse. Changing by the 10s and 20s, right? Okay. So that's it. I'm gonna plug back in my USB mouse, USB microphone. if you pay attention here, this is for the host controller device for USB. This HCD means host controller device, and this is for the USB. I'm just going to tell you. You can look it up in Google, right? And there you go. So now I know that my keyboard is interrupt 1. You can see that it is affinitized to CPU 7. That's my keyboard, right? My touchpad is interrupt 40 and 96, affinitized to CPU 6 and 7. And my wireless mouse and also USB microphone is interrupt 166 with the device name HCI. Sorry, hard for me to pronounce that. Okay, so now we know that. Now let's go a little bit further and deeper into Linux and understand what really happens in the kernel when those interrupts are triggered.